Okay, this says simplify and state the excluded values. So we've got to make sure to exclude values before we divide anything out. That's an important thing. So in this one, we would say, okay, we know we can't divide by 0, so a cannot equal 0, or else that would be 7 times 0 cubed, which would be 7 times 0, which would be 0. That's bad. And now that we've restricted, we can simplify. So 21 and 7, multiplication can be simplified, remember. So 21 over 7 becomes 3 over 1. A squared and a cubed becomes a on bottom. So left on top is a 3. On bottom, 1 times a, which is a. So this is our answer as long as a does not equal 0. On this one, to divide out anything, we have to divide out exact factors only. So once again, we're going to factor out the top. So on top, we'll pull out a 3. Left will be divide by 3, divide by 3. Left is x minus 2. On bottom, we'll factor the quadratic. What multiplies to be negative 6 adds up to be 1. 3 times 2, negative 2. So this factors to be x minus 2, x plus 3. Now you have to restrict the domain first before you divide anything out. So x cannot equal 2 and x cannot equal negative 3. And now we can divide them out. So our final answer is 3 over x plus 3 as long as x does not equal 2 and x does not equal negative 3. Okay, on top here, this tricks people. This is not in standard form, so you need to rewrite it correctly in standard form. So I'm rewriting the problem in standard form, and now we're going to factor out the top here. So on top, it's not considered factored if there's a negative in front. So remember, we'll factor out a negative 1, divide by negative 1, divide by negative 1. So left is w minus 4. On bottom, it's a quadratic. We factor what multiplies to be 16, adds up to be negative 8. Negative 4 times negative 4. So the bottom factors to be w minus 4 times w minus 4. Restrict the domain first. So w cannot be 4, w cannot be 4. Sorry. Divide those out now. So left on top is negative 1 over w minus 4 as long as w does not equal 4. Since these are the same value, you don't need to list it twice. Okay, with multiplication, remember that we can multiply straight across and divide out exact factors from top things to the bottom things. So it's really easiest to just factor each piece. That's factored, let's factor that. So I'm rewriting the problem 14x. The bottom, push pause, make sure you can factor it by yourself, because honestly, that's the hardest part for people is factoring it correctly, because they'll factor it wrong and then they'll divide out wrong factors. So then over here, this is already factored. On bottom, we'll factor out a 7, divide by 7. I don't know if I was recording when I did that problem. I hope I was. Crap, I hope I was recording during that. And there's no way for me to see. So hopefully you can look at my work and get some help there if I wasn't recording, but I was hoping I was. So with multiplication, we factor everything out. So I'm pulling out a 7, left is x minus 3. And now we'll restrict the values because that's in the instructions before you divide anything out. That's most important. So x cannot equal negative 5, x cannot equal 2, x cannot equal 3. So now we can divide out exact factors. So we have a 14 on top and a 7 on bottom. So that becomes 2, that becomes a 1. X on top, no x's on bottom. So that x is going to stay. We have an x plus 5, you have x plus 5 on bottom, yes. And so that's everything that divided out. So left on top was a 2 and an x. Left on bottom was a, looks like an x minus 2 and an x minus 3. As long as x does not equal 3, negative 5, or 2. Okay, with dividing fractions, we will flip the second and multiply. So let's just first focus on factoring each piece. So I'm going to pull out a 4. Left is k plus 2. I'm going to pull out a greatest common factor here. A 2, divide by 2. Do this correctly, please. And left is 3k minus 5. Let's just leave it as division right now and factor out this. So right now we have, I'm going to pull out a 2 to begin with. So divide by 2, divide by 2, divide by 2. So left is k squared plus 6k plus 8. Now that keeps factoring. Well, multiplies to be 8, adds up to be 6. 4 times 2. So we can quick factor that. So I'm going to erase that. We can quick factor that to be k plus 4 times k plus 2. And now we're pulling out the greatest thing here. We have a 3, so divide by 3, divide by 3. So left is 3k minus 5. So now dividing fractions is easy as pie. Look at the second fraction and multiply. So I'm going to rewrite out what I have here. So we're multiplication. This is going to come to the top. So that's 3k minus 5. And then this is going to come to the bottom. So we have our 2 and k plus 4 times k plus 2. And now we're going to restrict the values if it asks us to, and I think it does. So 2 doesn't have a restriction. All right, here we would set it equal to 0 and solve for k. So you'd say 3k minus 5 equals 0, solve for k. So you'd add 5, 3k equals 5, divide by 3. So we know that k cannot equal 5/3. For this piece, it's k cannot equal -4 and k cannot equal -2. So now we can divide out exact factors. We have a 4 on top and a 2 on bottom, so that becomes 2 over 1. We have a 2 on top now and a 2 on bottom, so those actually happen to divide out. Moving on, k plus 2 and k plus 2 divide out. We have a 3 on top, nothing that divides with 3 on bottom. We have 3k minus 5 and 3k minus 5. So it looks like left on top, all we have is a 3. Left on bottom, all we have is a k plus 4. That's our answer as long as k does not equal -4, -2, or 5/3. When adding fractions, this is one of the times you have to have a common denominator. So notice we have 6x here, we have 2x squared. So think about it. We can make this x and x squared. So we can make this x and x squared. So it looks like we're going to have an x squared in our denominator. And then we can make 2 6. So 6x squared is our least common denominator. So this is 6x. We need it to be 6x squared. So we're going to multiply by x over x. This is 2x squared. We need it to be 6x squared. So we're going to multiply by 3 over 3. So this piece becomes 5x over 6x squared because we multiply straight across. This piece becomes 9 over 6x squared. Check to make sure those really are the same. They are, so now we can combine them, everything. So on top, now we're just adding our numerator. So we have 5x plus 9 divided by 6x squared. Now this would be our final answer, but here's why. We would say that is my final answer, but does it simplify? This doesn't factor, and so we can't divide anything out. So that's how we know we're done. Okay, looking over here at 38. So we need a least common denominator. So we need to have all of our bottoms factored out. So this piece is really 5x. You should push pause on the video. Make sure you can factor this. X minus 2, x plus 2. And then right here, this is going to factor to be, so we have minus 3 over, push pause, make sure you can factor that correctly. So that piece becomes x minus 4, x plus 2. Okay, so least common denominator here is we have an x minus 4, we have an x minus 2, and an x plus 2. So we need all of our denominators to look like that. This has an x minus 2, check, and an x plus 2, check, so it needs x minus 4. So I'm going to multiply x minus 4 over x minus 4 to this piece. This one has an x minus 4, and it has an x plus 2. So that means it needs x minus 2. So we're going to multiply by x minus 2 over x minus 2. So then we multiply straight across. So let's just focus in on this piece here. So we have 5x times x, which is 5x squared. And then we have 5x times -4, so minus 20x. And then that's all over x minus 4, x minus 2, x plus 2. And then right here, focusing just on this piece, I'm going to distribute the -3 through, but the negative with the 3. Because then I'm taking care of all my negatives and distribution of the negative. Do not forget to distribute the negative through. So negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. And that's all over. If you multiply out the bottom, which we're going to leave it multiplied out, but in factored form. Now you can say to yourself, do I have a common denominator? Yes, we do. So that means we can now put this as one fraction. So on top, we're going to combine all like terms. So we have 5x squared, no other x squareds. And then we have negative 20x minus 3x is negative 23x. And then plus 6. And that's all over x minus 4, x minus 2, x plus 2. So this would be our final answer, but we've got to check to see if this top thing factors. So we would do what multiplies to be a times c, what multiplies to be 30, and adds up to be negative 23. So listing out factors of 30. 1 times 30, 3 times 10, 5 times 6, and that's it. None of those can add up to be negative 23, so it does not factor. So we know nothing will simplify. 39 says the length of a rectangular prism is 5 more than twice the width. The volume's this. What is the simplified expression for height? You've got to write yourself a problem. So it says length of the rectangular prism is 5 more than twice the width. So we don't know what width is, so let's call that x. Our length is 5 more than twice the width. So 2 times the width plus 5. 5 more than twice the width. And then we don't know what height is. So height is, we have no idea. Let's call that question mark. That's what we're trying to find. Since we're given volume, so volume is equal to length times width times height. So we're given this volume is 2w cubed plus 7w squared plus 5w. So we're setting up our true statements equal to length, which is 2x plus 5 times width times height. And then we're trying to solve for height. So we're trying to get height alone, so we'll divide by x and 2x plus 5, so both sides of the equation. Notice this has w's, this has x's. Let's just use the same variable. So instead of writing divide by x, I'm going to write divide by w. And then instead of write 2x plus 5, I'm going to do 2w plus 5. So we divided both sides by that. So our x's divide out, that divides out. So now question mark is alone. So this is the answer for question mark, but we just got to see if it simplifies. To simplify something like this, we factor it out, divide out exact factors. So on top, we'll factor out a w. Left is 2w squared plus 7w plus 5. On bottom, we have our w and then 2w plus 5. So then you would say, does these factor more? Well, multiplies to be a times c, which is 10, and adds up to be 7, 2 times 5. Now notice something. We've got a long factor because our leading term is a 2, not a 1. So we drop and break. So we are going to have this. 2w squared plus 2w plus 5w plus 5. So I'm just focusing on this piece and factoring it. So then in this group, we'll pull out a 2w, left is w plus 1. We'll pull out a positive 5, so w plus 1. Our safe haven's the same. So we pull out w plus 1, divides out, left is 2w plus 5. So I'm going to rewrite this one more time. We still have a w. This just became w plus 1 and 2w plus 5. And then on bottom, we have our w and 2w plus 5. That was equal to question mark. And so now we can divide out exact values. So that means question mark equals w plus 1. A square, so read number 40, a square has a length of 6x plus 2. A rectangle has this width. It says that they have the same area. And it says, what's the length of the rectangle? Okay, let's draw a picture here. So a square is the same length and width. So the area of this is 6x plus 2, length times width, times 6x plus 2. No need to multiply it out. Now our rectangle looks like this. Our width is 3x plus 1, and we're trying to find this. So our area for this is, area for this will be length times width, so question mark times 3x plus 1. Now it says the areas are equal. So if area equals area, then this equals this. So let's set that up. 6x plus 2 times 6x plus 2 equals question mark times 3x plus 1. Now we're trying to solve for the question mark, the length. So we're trying to get question mark alone. So divide by 3x plus 1, divide by 3x plus 1. So now question marks alone. So you'd say, okay, that's my answer, but does it simplify? The only way to simplify this is to have it all factored out. So in this piece, we could factor out a 2. So divide by 2, divide by 2, left is 3x plus 1. And this we can pull out a 2. And this is all multiplication, right? And so this is different than like, this is just factoring out what's common. This isn't factoring like a quadratic anyways. And then we'll pull out, and then we have left is 3x plus 1 in that piece. Divide by 2, divide by 2. So really we have 4, 2 times 2 is 4. And then we have our 3x plus 1 times 3x plus 1. And then on bottom we still have 3x plus 1, and that's what's equal to question mark. So we divide those out, and it looks like all that's left for question mark is a 4 and a 3x plus 1. So question mark equals 4 times 3x plus 1. That answer is acceptable, or you could multiply that in, 12x plus 4. Both would be an acceptable answer. All right. When solving these, now why is it solved? Because there's an equal sign. When adding and subtracting, you need a common denominator. When solving, we need a common denominator. So we're going to factor this out because we want least common denominator. So focusing on this piece. We have x minus 1. Push pause, make sure you can factor that. That becomes x plus 1, x plus 2. Then we have plus 2x over x plus 2, and that's equal to x minus 1 over x plus 1. So we need all of our denominators to be the same. So looks like this has an x plus 2, this has an x plus 1, this has an x plus 2, needs x plus 1. Most important thing is putting your parentheses. This has x plus 1, it needs x plus 2. Parentheses, parentheses, let's put, anytime there's two terms, let's go add in parentheses. Okay, focusing now on rewriting and distributing out these pieces. So that piece, we don't need to distribute anything, we didn't change it. So let's write out what we still have. And then we have, right here, we're now simplifying that, 2x plus, so plus 2x squared plus 2x. And then that's over x plus 2 and x plus 1. Now focusing on this piece, we've got to double distribute and combine like terms. So we have our equal sign. And now we're distributing with the top here and combining like terms. X squared plus 2x minus x minus 2. And that's all over x plus 2 and x plus 1. So I want you to notice something. All of our denominators are the same. This is only true with solving, but when solving, you can just ignore the denominators now that they're the same. So now let's just focus on combining like terms on this side of the equal sign. So we have 2x squared, and then 2x plus x is 3x, so plus 3x. And then minus 1 equals, over here we're combining like terms, x squared plus x minus 2. So now you say to yourself, I'm trying to solve this. So it looks like it's a quadratic, so we need to get it set equal to 0 and solve by factoring. So subtract x squared, subtract x squared, subtract x, add 2, add 2. So if we add straight down, we'll get x squared, add straight down, we get plus 2x, add straight down, we get plus 1 equals 0. Okay, we have our quadratic, it's set equal to 0, and now we're going to solve by factoring. So we're just solving for x, remember? So we do what multiplies to be a times c and adds up to be b. So push pause, make sure you can factor it. So x equals -1, x equals -1. Now, we need to check our answers with these always. So let's go back up to the top. So if we plug in -1, we'll have, I'm going to push pause and erase this and give myself some room. So plugging in -1. So right here we have -1 minus 1 over -1 squared plus 3 times -1 plus 2. Then right here we have plus 2 times -1 over -1 plus 2 equals right here -1 minus 1 over -1 plus 1. So let's check it. So simplifying this, we have -2 over, for this piece, this is what I'm simplifying, -2 over -1 squared is 1 minus 3 plus 2. And you could just type it into your calculator exactly like that. So we would get 1 minus 3 is -2 plus 2, which is 0. Uh-oh, right there we already see there's a problem. You can't divide by 0. So that must mean that -1 is an extraneous solution. And since that's the only solution we found, that would mean that there is no solution for this. So if we would have went through and checked it and it came out okay, like let's say that we plugged it in and got 5/4 equals 5/4, then we would have kept our solution. But we were dividing by 0, and so that's a problem. We can't divide by 0. Also, if you checked it and let's say you got 2 equals 3, for example, or 2/3 equals 3/2, that's not true. So that would also be a solution we throw out. Okay, let's solve this one. So we need a common denominator. Looks like we have a 2x, an x, and a 6. So let's make all of these 6x. So we multiply by 3 over 3. We multiply by 6 over 6. We multiply by x over x. So for this piece, we have 15 over 6x minus 6 over 6x equals 5x over 6x. Now that we have a common denominator, and only because we're solving, because this is not true for addition and subtraction, you have to keep the denominator for addition and subtraction, but since we're solving, we can just solve using the top. So we have 15 minus 6 equals 5 over x, solve for x. So we have 15 minus 6, which is 9, equals 5 over x. Now solve for x, so divide by 5. So x is equal to 9/5. Checking it, watch me check it. So we have 5 divided by 2 times 9/5 minus 1 over 9/5 equals 5/6. Now if you got to type this in correctly into your calculator, so you've got to use parentheses. So what I would do is just do 5 divided by, type that into your calculator, and then write down what you get. Because a lot of people will type it in wrong. So when you do that, you should get, right here we get 18/5 over 5. And then we have minus 1 over 9/5. And so now you'll type into your calculator, you have to type it in like this, 5 divided by parentheses 18 divided by 5. So you'll have to have parentheses. Let me just show you. Let me pull up my calculator. We're doing 5 divided by parentheses 18 divided by 5. I'm going to hit enter. I'm going to hit math, enter, enter. So we have 25 over 18. So this piece became 25 divided by 18. And then if you type, you'll type this piece into your calculator just like we did with that. So 1 divided by parentheses 9 divided by 5, and you will get 5/9. And then does that equal 5/6? So now you'll type into your calculator 25 over 18 minus 5/9. 25 divided by 18. And I should have used parentheses, so I'm going to start over. 25 divided by 18 minus 5 divided by 9. Math, enter, enter. Uh-oh. I think I might have typed something in wrong because I swear this one worked. That's a negative, and this isn't negative. What did I type in wrong? We're plugging in. We got 9/5. 2 times 9/5. Let's see. 5 divided by 2 times 9 fifths, close, close. (25/18). No, we did that right. Did I solve wrong? Let me look at my paper. Oh, that's good. And then we have 25/18 minus 5/9. What the heck? I swear this one didn't come out extraneous. I must have just not hit the right thing because I'm typing it in now. Just we figured out that first one was 18/25, and then we had -1 divided by 9 fifths. I get the right thing. So I don't know where I had. Oh, what the heck? Oh, 9 fifths. Did I type that in right? So it looks like this one was extraneous, but I didn't realize that. I'm bugged. All right, I'm just gonna let that one go, but I don't know if I checked it wrong or what's going on, because I swear I'm checking it right, plugging in. I swear I solved it right. 15 minus 6. So anyways, I'm just gonna let it go. Just be careful, check your answers. Okay, so looking at this next one, we're gonna not have to graph these, but answer these questions. So remember, to be able to determine all these things, you've got to have it in factored form. So y is equal to 1 over that factors to be x minus 4, x plus 4. So our discontinuities, we know we can't divide by 0, so we'd say x cannot equal 4, x cannot equal -4. So those are our discontinuities. So x equals 4 is a discontinuity, and x equals -4. Discontinuities are what it can't equal. We can't divide by 0. So now we would say, are those removable discontinuities or non-removable? Well, you can't divide those discontinuities out with anything on top, so they don't remove out of the equation. They don't simplify, so they aren't removable. So they're both non-removable. Then from there, wholes. Remember, wholes come if you have something like this, x plus 2, and then over x plus 2 and x minus 1. See how those remove? So that would be a whole at x equals -2. There'd be a whole. So notice neither of these divide out with anything on top. That's where holes come from if they're removable. So there is no holes for this one. So no holes. Our vertical asymptotes are what's left, and the discontinuities that didn't divide out. So neither of those divided out. So we have vertical asymptotes at x equals -4 and x equals 4. Horizontal asymptotes come from dividing the functions. So you always divide, you only focus on the leading coefficients, and you'll divide out if they can divide out, but you got to focus on the leading coefficients. So remember, it's really easiest to look back at the original and make sure it's all multiplied out and in standard form to do this, so that you can look at your leading coefficients correctly. Because if you do this, you need to have it distributed out. So I'm just going to look back here. So we're focusing to answer a horizontal asymptote. We're saying, does 1 divide by x squared at all? No, it divides 0 times. So our horizontal asymptote is at y equals 0. So remember, with horizontal asymptote, if you had something like if your leading coefficient was 2x squared over 3x squared, the x squareds would divide out, so we would have a horizontal asymptote at 2/3. Just a reminder. So our x-intercept is when y equals 0. So I'm going to put 0 here instead of a y and use algebra to solve. So we have x minus 4 and x plus 4. Solving for x, so we would get a common denominator, so we'd multiply by x plus 4, x minus 4. So then 0 times anything is 0. So we have 0 equals. And now we're just focusing on the top. 0 equals 1 because we got a common denominator we're solving. Now notice the variable went away, like we don't have anything to solve for. So that's not a true statement. So the x-intercept is there are no x-intercepts. So let's say we would have done that. We would have got a common denominator and got 0 equals x minus 2. Then we would have solved for x, so we would have added 2. So to both sides, so we would have had x equals 2. So then your x-intercept would have been at 2, 0. But that didn't work for this one because there wasn't a variable to solve for. Our y-intercept is when x equals 0, so plug in a 0 for x. So that's 1 over 0 minus 4 times 0 plus 4, which is 1 over negative 4 times 4, which is negative 1/16. So we plugged in x equals 0, so 0 and negative 1/16. Our domain is just easy, guys. You'd say it's all real numbers except x cannot equal 2 discontinuities or however many discontinuities. So x cannot equal 4 or negative 4. Okay, let's do this one. So to be able to determine the discontinuities, you've got to focus on factoring out the top and stuff. So I factored out the top. I pulled out an x to begin with. Then we had x squared plus 2x minus 3. Then you'll factor the quadratic. So this whole piece, this whole top thing becomes, push pause, make sure you can factor that all by yourself. So that was the top. The bottom factors out to be, if the quadratic, push pause, it factors out to be x plus 3 and x plus 1. Okay, so it says, what are the discontinuities? That's when the bottom equals 0. So x cannot equal negative 3, x cannot equal negative 1. So our discontinuities are at x equals negative 3 and x equals 1. So then let's divide out what we can. Oh, look, the negative 3 one removed. We just removed it. And nothing else divides out. So I'm going to write out my new equation. X times x minus 1, and on bottom x plus 1. Okay, so this one removed, so it was removable, and this one did not divide out, so it was non-removable. Holes come from removable discontinuities. So we have a hole at negative 3 comma something. So then you'll go and plug in, so we really have y is equal to this new function here. You go to the new function, and where the discontinuity, where the hole was, or the removable discontinuity, you'll plug in negative 3. So it'll be negative 3 times negative 3 minus 1 divided by negative 3 plus 1. Simplify that out, and we get negative 6. So our hole is at negative 3, negative 6. Our vertical asymptotes come from the discontinuities that don't remove. So the one that was left over, the one that didn't divide out, is our vertical asymptote, so x equals negative 1. Horizontal asymptotes come from the leading coefficients, and remember you need it to be multiplied out, so you wouldn't want to use that because look at the top, it's not multiplied out. Let's look back at the original. Now you just focus on the leading terms. Does that divide out? So we're doing x cubed divided by x squared. Does it divide out evenly at all? 0 times, like no times. So y, so we would say y, well, this one's not really y equals 0. This one wasn't a very bad one, so it wasn't a good one. So we'd just say y equals 0, even though that's actually not the case for this. But I'm not going to confuse you. So they don't divide out so evenly. So if it would have been, let's take for example, it would have been 2x over 4x, our leading terms, if they would have been that, then the x's would divide out. So 2 over 4, which would be 1/2, would have been our horizontal asymptote. But it didn't. They weren't the same. Okay, x-intercept is when y equals 0. So I am going to go back and use this new simplified one just to find this. So our x-intercept is when y equals 0. So we have 0 is equal to x times x minus 1 over x plus 1. Now think about it. If we get a common denominator, we're going to multiply by x plus 1 over x plus 1 to get a common denominator. 0 times anything, still 0. So we're really just focusing on solving the top. So, because remember with solving, all you have to do is get a common denominator and then solve using the top. So we're looking at 0 equals x times x minus 1. So we get x equals 0 is a solution and x equals 1. So we have two x-intercepts, except for, so our x-intercepts are x equals 0 and x equals 1. Now let's check our domain. Are those x values allowed? Oh, no, that was a discontinuity. Oh, no, wait. Oh, I wrote x equals 1, but it's negative 1. Okay, so yeah, we have two x-intercepts because both of those values are allowed. The only two unallowed values are negative 3 and negative 1. Our y-intercept is when x equals 0, so I'm going to go back here. Instead of plugging in y equals 0, we're plugging in x equals 0, so y is equal to 0 times 0 minus 1 over 0 plus 1. So we have 0 times negative 1 on top, which is 0 divided by 1, which is 0. So our y-intercept is at 0. So, and this would be written as a point. So this was 0, 0, and then 1, 0. We plugged in x equals 0, and we got out 0. And our domain is all real numbers except x cannot equal the two discontinuities, -3 and -1. All right, that's everything.